Dear students, today we will discuss on the problems related to resistances connected in series and how to make use of what is called as voltage divider rule. In the previous class, we have discussed on numerical problems by applying Ohm's law and Kirchhoff's law. And there we have seen that the elements are connected, interconnected with each other, either in the form of a loop and where the elements are connected in series, parallel like this. If we are trying to solve the problem, we have to know about how the current is distributed. So to solve such problems for Ohm's law and Kirchhoff's law, it is better to understand the distribution of current and voltage for series connection and parallel connection. Today, we'll be concentrating on series combination of resistors and voltage divider rule, so that by the end of the session, you will be able to solve numerical problems to determine equivalent resistance of series connected circuit. What are the currents in the resistors? What are the voltages across each resistor? So consider a DC series circuit. So what is the meaning of series circuit? If for example, I have a resistor and I have one more resistor, let us say this is R1 and this is R2. If I call this as A and B terminal, and this is C and D terminal. This is starting terminal, end terminal. Starting terminal, end terminal. If the end terminal of one resistor is connected to starting terminal of the other, and then they are left open like this. Now, if by chance I connect this to a battery and current is flowing through this, so what will happen? Current is nothing but the flow of electrons. So electrons flow in the opposite direction. Current flows like this. So if the current is flowing like this from terminal A through R1 to terminal B, and again continuously it flows through C, R2, D, and then goes out like this to the remaining part of the circuit. So here the observation is current is not dividing anywhere. It is just passing through the resistors. It means current through resistor R1 is I and current through resistance R2 is also I. Same current flows through the resistors when they are connected in series. If for example, I have another resistor like this. Now what happens? Current I is coming and dividing there. So now R1 and R2 are not in series because they will carry different current. If this is not there, no resistor is connected, then only R1 R2 are there, same current flows through this. So if this, I call this as I1, this as I2, and this is I, all are same. I is equal to I1 equal to I2. That is the series connection. See here, the DC circuit in which resistances are connected end to end, so that there is only one path for current to flow, is called DC series circuit. So let us consider a simple circuit with three resistors R1, R2, and R3 connected in series like this. And this total series connection between A and B is connected to a voltage V. So we are connecting a battery across this terminal A and B. Now, when there is a closed path formed and potential difference is existing, current starts to flow. Let the current coming out from the battery be I. So this I flows through this wire and then to resistor R1, R2, R3 like this. Okay. So same current is flowing throughout this one. So this is called as series connection. And as there is a closed path, it is called as series closed connection. Okay. Now, uh, if for example, because of the current flowing through resistance R1, there is voltage developed across this. How it is developed? Because of Ohm's law. What is Ohm's law? Ohm's law states that voltage developed across the resistor is proportional to the current flowing through it, and that proportionality constant is R. So V is equal to I into R. Okay. So now, if V1 is the voltage developed across R1, V2 voltage across R2, V3 voltage across R3. Now let us see what are these voltages. So V1 is current through resistor into this resistance value. What is current through resistor? I. So I into R1 will be V1. So V1 is I into R1. Similarly, what is V2? I into R2. What is V3? I into R3. So now you apply KVL, Kirchhoff voltage law, around this loop. Okay, around this loop you apply Kirchhoff voltage law. So what happens now? If you see here, from this point there is voltage rise, because this is minus and this is plus. You are moving from minus to plus, voltage rise. Now current is flowing like this. So current is flowing like this means this is plus and this is minus. So current is flowing like this. It flows from higher potential to lower potential for passive elements. So plus, minus. So current is flowing like this. So this is plus and this is minus. And this is, current is flowing like this, but this is active element. So it is minus, this is plus. Okay. So now I can write KVL here. What is that? Voltage rise V. These are voltage drops, plus to minus, plus to minus. So V minus V1 minus V2 minus V3 equal to 0. So I can write a KVL equation as V minus V1 minus V2 minus V3 equal to 0. So rearranging, I will get this equation. V is equal to V1 plus V2 plus V3. But what is V1? It is nothing but I into R1. V2, I to R2. I into R2, V3, I into R3. So I is common because same current flows throughout. So that becomes V is equal to I into R1 plus R2 plus R3. Now let us say this is 1 ohm, this is 2 ohms, this is 3 ohm. I can add them. 1 plus 2 plus 3, 6 ohms. So I can add this and this will become one single resistor. So therefore, this R1 plus R2 plus R3 is nothing but what? V by I. That is represented by an equivalent resistance called as series equivalent resistance. Series equivalent resistance. RS is series equivalent resistance. And what will be its value? R1 plus R2 plus R3. So what does it mean here? If three resistors are connected in series, I can represent it by a single resistance like this. So three resistors connected in series can be converted into a single resistor RS between the same terminals AB and same voltage. So what current was flowing before, same current will flow because these three resistance are now replaced by single resistance. When is that possible? When this RS is R1 plus R2 plus R3, then same behavior will be there. Yeah. So what are the main characteristics of a series circuit? What is the observation made? The current in each resistor is the same. Same current flows through all the resistors. Then the total resistance is equal to sum of the individual resistances R1 plus R2 plus R3. So if there are 5 resistors, R1 plus R2 plus R3 plus R4 plus R5, like that. Okay. So next, so RS can be written like this, and the total power dissipated in the circuit is sum of the powers dissipated in individual resistances. So what is the total power absorbed by the circuit? It is power absorbed by R1, power absorbed by R2 plus power absorbed by R3. If I add all these powers, I get the total power supplied to this circuit. That can also be verified here. See, we have RS is equal to R1 plus R2 plus R3. And if I multiply I square throughout, same current is flowing, I square into RS is equal to I square R1 plus I square R2 plus I square R3. So what is I square into R? As per Ohm's law. So we have from Ohm's law, V is equal to I into R. Okay. Now, if I multiply I get what? V into I is equal to I square into R. What is voltage into current? It is nothing but power. Voltage into current is nothing but power. So power is, other formula is I square into R. So therefore, this is nothing but total power absorbed by the circuit PS. It is power absorbed by R1, power absorbed by R2, power absorbed by R3, or power dissipated in R1, power dissipated in R2, power dissipated in R3. Actually, power is absorbed by the resistor. That absorbed power is not stored inside the resistor. It dissipates in the form of heat. So therefore, power absorbed or power dissipated meanings same. So the total power dissipated in a series circuit is equal to sum of powers dissipated in individual resistances. So now let us go to what is called as voltage divider circuit. If two resistors, for understanding, we will consider two resistors R1 and R2 connected to a supply voltage V. Okay, when it is connected here, what will happen now? Same current flows throughout. Okay, current is flowing, I is flowing, the same current I will flow. There is no current here because it is open. Current flows only if there is a closed path. Okay, so now let us say voltage across R1 is V1 and voltage across R2 is V2. Now what is happening is this total voltage is divided into V1 and V2 for R1 and R2 resistors. So what is that we can find here? The basic idea behind the voltage divider is to assign a portion of total voltage to each resistor. Some portion of this voltage is allotted to R1, some portion of V is appearing across R2. So what are those voltages? What is V1? What is V2? In terms of V, R1 and R2. If I know R1, R2 values, if I know V value, I can find out V1 and I can find out V2. Yes, how? See here, as the same current is flowing, now what is the current now? The current is total voltage by total resistance. So V divided by R1 plus R2. So I is equal to V by R1 R2 and this R1 plus R2 is the total resistance. You can write it as RT or RS, series resistance equivalent value. So now what is V1? This V voltage V1 is equal to what? Current into resistance. So V1 is I into R1 and R1, this I can be written as what? V by RT. So I is V by RT into R1, I into R1. So V divided by RT into R1. Similarly, V2 is equal to I into R2 and that is V by RT into R2. So we can write it as V1 is equal to voltage into R1 divided by R total, which is equal to what? V into R1 divided by R1 plus R2. Okay. Similarly, V2 will be equal to what? This is R2 now. R2 divided by R1 plus R2 into total voltage. So if two resistors are connected in series, voltage across individual resistance is equal to total voltage into resistance of that element, that is V into R1 divided by sum of the resistors connected in series, that is R1 plus R2. Okay. So that is this one, V into R1 divided by R1 plus R2. So let us now solve problems. Using voltage divider rule, determine V1 and V2 for the circuit shown. So here total voltage is 1000 volts. We have to find what is V1 and what is V2. R1 is 1 kilo ohms, 1000 ohms. R2 is 999 kilo ohms. That means 999 into 10 cube ohms. So how will you find V1? V1 is equal to what? Total voltage. Now they have given us VT. So total voltage VT divided by R1 plus R2 into R1. So that is equal to total voltage is 1000 divided by R1 plus R2 is how much? 1 kilo ohms, 919 kilo ohms. That is 1000 kilo ohms. That means 1000 into 10 cube into R1. R1 is how much? 1 kilo ohm. That means 1 into 10 cube ohms. So 1000 will cancel. 10 cube 10 cube will cancel. So V1 will become 1 volt. Okay, V1 is 1 volt. So out of 1000 volts, only 1 volt will appear here. And here, what will be V2 now? V2 is equal to total voltage VT into R2 divided by R1 plus R2. That is equal to 1000 into R2 is how much? 999 into 10 cube divided by R1 plus R2. 1000 into 10 cube. So what will happen? 10 cube, 10 cube will cancel. 1000 will cancel. We'll get 999 volts. So V2. V2 is 999 volts. So total is 1000 volts. Here 1 volt will appear. Here 999 volts will appear. Okay, 999. So the voltage, some portion will appear for V1, some portion will appear as V2. See here, if two resistors are connected in series, the small resistor is 1 ohm, large resistor is 999 kilo ohms. Small resistor will have small voltage and large resistance will have large voltage. So now try this one. Find the voltage V minus V1. So this is total voltage V, and this is V1. V minus V1 means this one. This will be V minus V1. This voltage you have to find for the following circuit. So now this I can write it as what? Instead of three resistors, I can just represent it as two resistors. So this is voltage V, this is R1, and here we have what V1. Okay, and this R1 and R2 and R3 they can be combined as a single resistance RS. That is nothing but R2 plus R3. Okay. Now this voltage I want. What is this voltage? This voltage is nothing but V minus V1 is equal to, let us say I will call it as V2, is equal to V2. It is nothing but total voltage into resistance of that element, that is R2 plus R3 divided by total resistance R1 plus R2 plus R3. So this is equal to, yeah, that's all. Values are not given, so you have to represent the equation like this. Yeah. V minus V1 is total voltage V into R2 plus R3 divided by R1 plus R2 plus R3. So, dear students, we have discussed on how the resistors are connected in series and what will be their behavior. That is, currents are same in all the resistors. Voltage will be dividing into different voltages, and to find these individual voltages, we can use what is called as voltage divider rule. So, having completed discussion on series connected networks, now students you should be able to determine equivalent resistance of the circuit, currents and voltages of series combination of resistors, and apply voltage divider rule. So for this, you can refer this textbook K. Umarov, Basic Electrical Engineering. For this topic, refer chapter 2, topic 2.9. Thank you, students.